Hello, Brett Nelson, another tutorial in Flexsim. This one covering process flow or line balancing. Essentially, how do you make sure that you don't have serious bottlenecks in your flow and a large buildup of WIP? I have a simple model here. I'll just get it running with three processors running in sequence, each with its own queue and each with its own assigned operator. I've got the operator set up so that they deliver from the queue and are required for the setup of the machine and then deliver to the next queue. The first and the last processor I've got intentionally set to run a little bit faster. So they have a setup time of 0.2 minutes and a cycle time of 1 minute. And my processor in the middle, I have a slightly longer setup time of 1 minute and a 2-minute cycle time. So you can predict what will happen if I speed the model up a little bit. We're going to see that there's a buildup of WIP in front of this slower second operation and no WIP at all in front of the final operation. So this is a clear indicator that we have a bottleneck machine in the middle of the process. That's not a good thing for a balanced line, and so this is something that we should try to resolve in our model. I'll also point out that we have a buildup of WIP in front of the first machine. Now, you could consider that to be a bottleneck, but I would suggest that that's really a scheduling problem with the supplier. We're delivering material into the system faster than the system can accommodate it. Of course, in a real world, and if you're a lean practitioner, we would look at cycle time reduction or setup time reduction and trying to find other ways of reducing the effort, improving the value add output. But let's say for now that we can't actually change the setup time and cycle time of the machines. We can, however, control our supply rate from the source. I'll come back here just for a moment. So knowing that I've got on the first process a 0.2 minute setup time, it's only running one piece at a time, plus a 1 minute cycle time, that I'm going to need at least 1.2 minutes for every part. But my supplier is delivering a product, typically once per minute. There's an exponential function, so it could actually deliver a little bit sooner. So it might be reasonable for me to stretch this out and say only deliver an item every 1.3 minutes. I'll stop, reset, and run the model with these new settings. And now I can see that the material is being consumed. Maybe I'll just slow this down a little bit. The material is being consumed roughly at the rate that it's being supplied. So now I've got a system where theoretically I'm not going to have this large buildup of excess material at the beginning of the process, but I still have a problem or a bottleneck in the middle of the process. Again, assuming that I can't improve or reduce the actual cycle time here, which is, if you're doing this in a real world, that's not cheating, that's a good thing to do. But if you're building a model, you shouldn't just solve problems by just bringing all your numbers down to something that's not actually possible or realistic and pretending that that's a good solution. A simple answer here, because the cycle time of this machine is 2 times the cycle time of the first and the second machine, or the first and the third machine, we could just duplicate the machine and have 2 machine centers. So I'm going to pick this processor, copy it, come and find a blank space, and paste a new processor. The advantage of doing this cutting and pasting instead of dragging in a new one is that it copies over the settings of the first as well. So it's still got the same setup time, the same processing time, and it's using an operator for the setup. It's using a transport to deliver the material. And so all I need to do now is do a center port connection between the operator and the machine. And I also need to connect it into the process flow. So I'm holding the A key down and connecting the flow from the queue to this machine and to the output queue. So now I have a second machine in the system, and it's running in parallel, and you can see that it's the queue is delivering to both of the machines. I'm going to stick in a little bit of an alternate sort of set of solutions here, and I hope it doesn't confuse my video too much, but I'm going to come back now to my source just for a minute. I talked about stretching out the inner arrival time to match the system so that I don't have this buildup of WIP at the front end. And that's great. This is certainly a solution, but I would argue that just changing or just having materials flow through the original source one piece at a time is not very realistic. We tend to, right, get a shipment of materials. So you get, a skid or a box or a cart or a tray or a pallet or however it's coming to you. It's going to come in as more of a batch, and that gets unloaded for the first process, or the tray or the cart gets wheeled over to that machine or to that process, and then they work on all of that batch of materials instead of having pieces come to it sort of one at a time, which is the default setup here, and that's what's represented by this inter-arrival time. So I'm going to suggest a better alternative to delivering material into your system, and that's to use this arrival schedule. I'm going to click on the arrival schedule, and then it opens up this new element down here of a table. And if I edit the table, now I've preloaded it. Oh, let's see here. I'll take it back to the default. It would come up with arrival time of 0, quantity 1. So just gonna, as soon as I click run, it will deliver one piece, and that's it. That's not really what I want. Maybe I want something like 4 deliveries during the day. So at the beginning of the shift, I want some number of pieces, and then if my shift is going to be something like an 8-hour shift, then maybe I want at 2 and at 4 and at 6 hours, 2 hours, which will be 120 minutes. My default is in minutes. 240 and 360. So every 2 hours. Now, it means that I have to deliver 2 hours worth of material. And I think I found that about a part every 1.4 minutes is going to take care of my, one part every 1.4 minutes gives me a nice sort of balance. So now I need to have 2 hours worth of parts at 1.4 minutes. So let's see. Hey Google, what's 120 times 1.4?
The answer is 168.
Okay, so I need to deliver 168 pieces every 2 hours. The default is to not have the table repeated. Let's try it. So we're going to do a reset. Now, it looks a bit strange, right? Because now I've got 2 hours worth of material that just got delivered. And let's see how well I did. So my model starts at 8. I'm going to speed things up. Here's 9. And at 10 o'clock, we delivered a bunch more. Okay, again, depending on all your model timing, you're going to have to find something that works. Okay, so this is, to me, a really good way of controlling the flow into your model is to set up an arrival schedule. There's some advantages to this too. There's some other advantages that I don't want to talk about here, but I'm just going to point out. Because we set up this arrival schedule table, right now I have no labels assigned because I'm in this demonstration, I'm not really assigning any labels, or I don't need any. But here is why I really like the schedule is it's the quickest way of attaching labels to the product coming in. So if you have some kind of a scheduling and dispatch system, or like a dispatch and pick system, or you want to identify different kinds of product to come in, you can now say you can have a product type and say the first shipment is type 1, and then I've got type 2, then type 3, and then type 4 product coming in. And being able to attach a label to the material like this gives us options, some fun options on the way down that we can start applying some logic, and depending on the type, so we can control the setup time or the cycle time or the inspection time or which machine it goes to, all that sort of stuff based on the product label that comes through. Okay, while that's chugging away, I want to talk about another option for the second processor. I have in my mainstream of this video where I added a second processor beside it, a parallel processor, and that split the work. There's other ways of doing this too. I want to talk about how many pieces a machine can run at one time and the idea of batching. Right now, the default for a processor is a maximum content of one piece. In other words, the operator will take one part, put it on the machine will set that one part or set up the machine for 1 minute and take 2 minutes to process that one part, and then they'll go back and take out one more part, set it up for a minute, run it for 2. One part, set it up for 1, process it for 2. And that may also not be very realistic. So let's say that this machine can process 10 pieces at once. And it will only take one setup for all 10 parts now. The processing time may still just be 2 minutes per piece. The machining time for each part may still be 2 minutes, but now we're going to spread the setup time over a larger batch. And that's going to make this machine more efficient. Now, in order for this to work though, I'll just do a real quick stop, bring my speed down to something reasonable and run it again. You're going to see though that this by itself isn't working. The content of this machine is still one part. And the problem is the queue isn't paying attention to the machine capacity. It's not collecting 10. It's just feeding them as soon as it can. It's just going to give them to the machine. And here, okay, so my current content goes 1, 2, 3 parts, but it's not doing the batching the way I expect it to do. So in order for that to work, I have to select the queue, and you can see here the default is for the batching to be turned off or unselected. If I click on it, then I'm now saying perform batching. And I want to set the target batch size to match the machine capacity. So in this case, I set a machine capacity of 10, so I want the target batch size to be 10. You can see the queue has parts, but it's holding on to them. It's batching them to build up 10 parts. And once it's got 10 parts, just to give it a moment, now it's released it to the machine. The operator took 1 minute to do a setup and then processed all 10 parts. I probably need to change my processing time. So now this machine is going to take 20 minutes. It's got 10 pieces in it, and it's processing them for 20 minutes. But if we look at the efficiency, that's already an improvement because we're not setting up for every single piece, we're setting up for a batch. This is where I want to introduce the idea of dashboards now. If I click on the top line menu, I've got the word dashboards show up. And because I don't have one, my option here is to add a blank dashboard. With a dashboard selected, my library now changes over on the left-hand side. There's built-in charts for displaying the content, for displaying the rate of output, stay time, or the state of the machine. So I'm going to click and drag the state chart. I'm also going to choose the state Gantt chart. We have to add some objects. So I'm going to click this plus key here, and then select objects. And now I have a list comes up where I can choose things from my model. I want to track my processors. Process 1, 2, 3. By comparison, I want to show you the second option of this chart. I'm going to do the same thing. Select my 4 processors. And that's all I need to do to get the chart started. It's all built in, the functionality is built in. Now it knows what I'm trying to track, and the chart design has already been set up by these defaults. I'm going to reset and run my model. I paused the video for a minute to give me an opportunity to figure out what was wrong with this state bar chart. It wasn't displaying anything, and I'd had this happen to me before. So what I discovered under the state profile here, I'll just highlight this, under the state profile, this row was blank. So I just clicked the down select, and there was only one option, state table. I chose the state table, reset and ran my model, and now it's working just fine. What's useful about this? Okay, so let me differentiate first. The state bar chart now is in a single bar, it's giving the kind of percentages of the different states for each machine. When we connect in a second machine, I also want to point out another option that you have. With the queue that's feeding these machines, the default is to send to the first available port. It's always going to try to send to slow op 2, and as long as it's available, it will send the material here, whether or not this machine is available. So you could also get a real imbalance in machine utilization. I would argue if we've added a second machine here to run in parallel, even if they don't run at the same speeds, instead of sending to first available, having this logic by default, I would choose round robin, which means feed each of the outputs in turn. But now we've got a nice balance, at least, between the two machines. It's not favorably running on just one machine. You can also see why I tend to like this state bar chart. You notice I've been referring to it more often than the state Gantt chart. The Gantt chart gets pretty crowded once I'm running for several hours here. You know, I'm at 3 hours into the process, and all these state changes are happening very quickly in my model, like minute by minute by minute. And so this gets really compacted down to something that I can't see for very well. I can also add the operator to it. And if I just pick on the 3 operators, I'm going to get rid of the Gantt chart and just make more room for my bar chart. The same bar chart will now display the operator status. They are idle for quite a bit more time because the way I program the machines is they need an operator for the setup, but they don't need an operator while they're running. And running the model like this, it might look like these 3 operators are all busy, but in fact, they're not really busy at all. Only about 19 or so % of the total time are they actually working. You can see the idle time of all 3 is about 80%. It's a nice job if you can get it, but you might consider then in this kind of a case, I will take this fellow and fire him. There's a good example where we want to set up an interesting logic on one of our processors. For some people, especially in a quality function, you might have something like an inspection station. I'm going to rename processor 3 to be inspection, just to make it clear. And I've also taken the liberty of replacing the basic green processor with a CMM machine that I found on the 3D warehouse. I've also then connected a second queue to the output. So the inspection can either go to this accept queue, and just to make it a bit more convincing, I'm going to change the color of this queue to green, and I'm going to change the color of this queue to red, and then it's very obvious what we're trying to accomplish here. But right now, the inspection just like the last time, our queue is set to go to the first available port, which in terms of queues is always going to be this first accept queue. So right now, 100% of the parts are going to leave the inspection station and go to the accept queue. A nice simple way of simulating some kind of a rejection rate is to change the logic of the inspection station output. Under the processor, we have the output first available, and I'm going to select the pull down, and instead of first available, if you hover over random, you're going to find these three choices: random port, random available, and by percentage. Okay. If I set up by percentage, then it's saying specify the percentages up to a total of 100 and their and which port to go to. So right now, 100% of the parts will go to port 1. Let's say I have, I don't know, a not splendid 96% first time yield. That'll go to port 1. And now I need to tell it where to send the other 4%. These have to total 100. So 96 and the 4%, I want to go to the second port. There we go. About 4% of them should be delivered to the reject pile. I've also added on my dashboard, I found, let me click on the dashboard here. I found a content, and I've picked the content chart and added it here. And I've clicked on or selected within the content chart the accept and reject queue. So it's keeping just a nice easy count of how much material is going to each output. If I wanted to, I could feed this queue back into one of these processors. I'm going to set this trigger up that on entry, I'm going to set visual, set object color, and instead of the color being random, I want the color to be red. So now when parts are rejected, the box turns red and we have a little bit better visibility. Maybe if I slow the model down just a little bit, we can see it being reworked, and the red parts are now coming back into our accept queue.